Hi everyone, so now let's look at another example here. So in practice 3 it says using the properties of limits in the graphs below, compute the following limit. Okay, so what I want to do first is just look at the limit here, and it says find the limit as x approaches 0 of f of x times h of x. So before I do anything where I'm starting to use properties of limits, I want to first just make sure that the limit as x approaches 0 of f of x exists, and that the limit as x approaches 0 of h of x exists. So I'm going to write that over here. Let's figure out the limit as x approaches 0 of f of x, and the limit as x approaches 0 of h of x. Okay, and then looking at the graph, you can see that the limit as x approaches 0 of f of x is 1. But whereas the limit as x approaches 0 of h of x doesn't exist, right? Because here we want to just notice that the limit as x approaches 0 from the left of h of x is equal to 3, but the right-handed limit, right, the limit as x approaches 0 from the right of h of x is equal to 0. And so since the left-handed and right-handed limits don't match, right, the limit as x approaches 0 of h of x does not exist. Okay, so this means that we can't directly use the properties of limits here. So this means we can't use the properties properties to say that the limit as x approaches 0 of f of x times h of x is equal to the limit as x approaches 0 of the first thing, the first function, times the limit as x approaches 0 of the second function. Okay, so we can't. So this is a no. Okay, so what we're going to do instead, since we can't directly use the properties of limits there, what we're going to do is consider the left-handed limit and the right-handed limit of f of x times h of x. Okay, and that way we will end up using the properties of limits for each, the left hand and the right hand, because notice here that the left-handed limits and the right-handed limits for both functions do in fact exist. Okay, so here I'm going to say that the limit as x approaches 0 from the left of f of x times h of x is equal to the limit as x approaches 0 from the left of f of x times the limit as x approaches 0 from the left of h of x. Right, so here I'm using property 3, which says that if we have a product of functions, that I can say it's the limit as x approaches 0 from the left of the first function times the limit as x approaches 0 from the left of the second function. Okay, and so now this will give me 1 times 3, right, which is just equal to 3. Okay, and then now I have the right-handed limit to consider. So same idea, I'm going to use property 3 again and say that this is the limit as x approaches 0 from the left of f of x times the limit as x approaches 0 from the left of h of x. And so now this will give me 1 times 0, which is 0. So now looking right at the left hand and the right-handed limits, do they match? No, they do not. So overall we know that the limit as x approaches 0 of f of x times h of x does not exist. Okay, so now at this point you might be wondering, well, why couldn't we just say that the limit as x approaches 0 of f of x times h of x is equal to 1 times does not exist, which doesn't exist? All right, again, we can't use the properties of limits at that stage to say that Okay, because in this case, it turned out that even with you making that error, you would have came to the correct conclusion where the limit, yes, does not exist in this case. But there are other examples where even though it seems by that logic that the limit shouldn't exist, there are some examples where they actually do. Okay, so I could give you, which I will actually tomorrow in class, two graphs of these functions here and ask you to compute the limit, and it would seem by that logic that it's not going to exist, but it actually will. Okay, so you want to make sure that you know when you can and can't use the properties, and so I will have you explore that more further in class.